Hey guys, we're continuing solving problems from Fundamentals of Physics by Halliday Resnick Walker. In this session, we'll solve problem number 33. I'll just read out the question. In figure, particle 2 and 4 of charge minus E are fixed in place on a y-axis at y2 equal to minus 10 centimeter and y4 equal to 5 centimeters. So 2 and 4 are fixed on y-axis. They are having same charges minus E, and particle 4 is at a distance of 5 centimeters from the origin, and particle 2 is at a distance of 10 centimeters from the origin on the negative side. Particles 1 and 3 of charge minus E can be moved along the x-axis. So particle 1 and 3 are on x-axis and can be moved on x-axis. Again, they are having the same charge minus E. Again, minus E. Particle 5 of charge plus E, okay, particle 5 of charge plus E is fixed at the origin. So this one is particle 5. It is fixed at the origin with a charge of E plus E. Initially, particle 1 is at x1 equal to minus 10 centimeters and particle 3 is at x3 equal to 10 centimeters. So initial positions for particle 1 and 3 are given. Part A. To what x value must particle 1 be moved? So you have to move particle 1 now. To what value of x must it be moved to rotate the direction of the net force on particle 5 by 30 degrees counterclockwise? And then part B, with particle 1 fixed at its new position, to what x value must you move particle 2? So you have to move now particle 3, to rotate F net, to rotate the net force back to its original direction. Okay, so let's see what question is asking us. We have 5 particles. Out of 5 particles, 3 are fixed. Particle 4, 5 and 2 are fixed. Particle 1 and 3, their initial positions are given minus 10 and plus 10 centimeters. But then you can move them. Okay, you can move them. I'll first draw the forces. Okay, let's do it step by step. I'll first draw the forces on particle 5. Remember, particle 1 and 3 are negatively charged. 1 is negatively charged. 3 is also negatively charged. 2 and 4 are also negatively charged. All of them are having value of E. 5 is positively charged plus E. So 5 will be attracted by all the forces, all the other charges. So let's draw them. Let's use yellow this time. We have particle 5 here. Particle 5 will experience attractive force from particle 1. So force on 5 due to 1 will be in this direction, in the negative x direction. Okay, in the negative x direction. So it's in this direction. F5 Okay, F5 Particle 5 will be attracted by 3 also. So force on 5 due to 3 will be this way. Okay, attractive force in the positive direction of x-axis. So this is force on 5 from 3. Particle 5 will also experience force from attractive force from 4 and from 2 as well. So force on 5 due to 4 will be in this direction. Force on 5 from 4 and force on 5 from 2 is in this direction. Now note that 1 and 3 are having same charges. Both are E. And they're also at the same distances. This is at 10 centimeters on the left side. This is at 10 centimeters on the right side. So charges are same, distances are same. So these forces will have same magnitudes. So if these forces are having same magnitudes, they will simply cancel out. Okay. Then what about 5, 4 and 5, 2? 4 and 2 are also having same charges. Charge magnitudes are same. But 4 is closer to 5. So this distance is less than this distance. So if 4 is closer to 5, force due to 4 will be greater. Charge magnitudes are same, so charge is not going to affect anything. But then this distance is smaller, so force on 5 due to 4 will be larger in magnitude. That is the reason I have drawn 5, 4 longer. So net force, these two are cancelling out. The net force will be in this direction, okay, because this one dominates. Net force will be subtraction of the two and is in the upward direction. I'll redraw it here. So net force on particle 5, net force on particle 5, net force on particle 5 is equal to F54 minus F52. F54 minus F52. So there is no force along x-axis, they cancel out. So net force only has y component. Okay, net force only has y component and it is in the positive y direction. Okay, it is in the positive y direction. Is that fine? So let's first find out this net force. What is this equal? Okay, what is this equal? I'll do that on the next page. F5 is equal to F54 minus F52. Remember they are in opposite directions, so subtraction. F54 minus F52. So this one is gamma Q5, Q4. Both of them are E. So E square. Only charge magnitudes. Okay, only charge magnitudes. Divided by 5 and 4 are separated by 5 and 4. 5 and 4 are separated by 5 centimeters. Here, 5 centimeters. And 2 and 5 are separated by 10 centimeters. Okay, 10 centimeters. I'll keep it here. So 5 and 4 are separated by 5 centimeters. So 5 into 10 to the power minus 2 square minus gamma Q5, Q2. Again, both of them are E. So E squared divided by 5 and 2 are separated by 10 centimeters. So 10 into 10 to the power minus 2 square. So this is gamma E squared. I'll take common. 10 to the power minus 2 whole square. So that's 10 to the power minus 4. And 10 to the power minus 4. Again, I'll take this common. 10 to the power minus 4. We're left with 5 square is 25. Minus 10 square is 100. Okay. Now I'll again take gamma E squared divided by 25. I'll take common. 25 into 10 to the power minus 4. We're left with 1 here minus 1 by 4. Now 1 minus 1 by 4 is 4 minus 1 is 3, 3 by 4. So this is gamma E squared divided by 25 into 10 to the power minus 4 into 3 by 4. Okay, into 3 by 4. Now 4 into 25 is 100. 100 is 10 to the power 2. Okay, let's write it here first. Gamma E squared, and this 3 is there, divided by 100, which is 10 to the power 2, into 10 to the power minus 4. So this becomes 3 gamma E squared divided by. Now this thing bases are same, powers are added, 10 to the power minus 2. If I take 10 to the power minus 2 upstairs, it will become 10 to the power plus 2, which is simply 100. So this becomes 300. So F5 is equal to 300 gamma E squared. Yeah, that's it, 300. 10 to the power minus 2 upstairs, it becomes 10 to the power plus 2. 3 is already there, so it will become 300. This is initial force on particle 5. Okay, this is initial force on particle 5. And this force is in the upward direction, in positive y direction. Okay, it's in the positive y direction. Now, what are we asked to do? Okay, now what are we asked to do? We're asked to relocate particle 1. Okay, we have to relocate particle 1 and find its new position such that the net force rotates counterclockwise by 30 degrees. Counterclockwise, so it will go into the second quadrant. It rotates counterclockwise by 30 degrees. Meaning, now net force must be somewhere here. F5 must be somewhere here. So you have rotated it by 30 degrees. You have rotated it by 30 degrees. And for doing that, you have to only change position of particle 1. You don't have to do anything with particle 4, nothing doing with particle 2, nothing doing with particle 3. You just have to relocate particle 1. By relocating particle 1, force on phi due to 1 will change. Rest everything will remain same. Okay, rest everything will remain same. So this force will remain same, this force will remain same. If these two remain same, then net force in y direction now. Okay, in y direction remains the same. Okay, so y component of the net force, this one here, let's use this one. I'll call this y component of the force. It is going to remain same because we did not change anything along y-axis. We did not change anything along y-axis. So it will just continue to remain same, F5-4 minus F5-2. The difference is that initially this was the net force and now this is y component of the net force. Okay, net force is now here. Now if net force is there, then it has a yx component also. X component in this direction. I'll call that Fx. That x component is in the negative direction. That x component will be in the negative direction if F5-1 is greater than F5-2. Remember, they were same. That's why they cancelled out. That's why there was no force in x direction. Now you have to have force in x direction, and that too in negative direction of x-axis. So this must be greater than this one. So meaning we have to increase this force. Because this is the only one we are allowed to change in first part. We are only allowed to relocate particle 1. So only force on phi due to 1 will change. Force on phi due to 3 will not change. That will remain same. So this force remains same. We have to increase this force. If we increase this force, then only x component will become in this direction. So this x component in magnitude, okay, in magnitude will be F5-1 minus F5-3. This one minus this one in magnitude, okay, in magnitude. Okay, now, so we have to increase F5-1. If we have to increase force on 5 due to 1, we'll have to bring 1 closer to 5, okay. Let's suppose somewhere here. Okay, I need to use another color. Let's relocate it here at a distance of x from particle 5. At a distance of x. So distance of particle 1, new distance of particle 1 from 5 is x. So position of 1 will be minus x then. Okay, because it is on the negative side. X centimeters, all distances are in centimeters, so I'll take this in centimeters. Okay, I'll take this in centimeters. So we have decreased the distance between 1 and 5 with the result this force will increase, force on 5 due to 1 will increase. With the result, we'll have some x component of force in the negative direction. And that is the only way net force, which was here, will rotate into the second quadrant. And we have to rotate it by 30 degrees, remember that. Now tell me, now we'll deal with this figure, with this diagram. If this one is Fx, then this one is also Fx. Now tan of theta is opposite side divided by adjacent side. So Fx divided by Fy. So tan of theta, now this is part A. Tan of theta is equal to Fx divided by Fy. Now normally you must have seen tan of theta is y component divided by x component. Y component divided by x component. But that angle is with x direction, x-axis. Then it becomes y component divided by x component. Here angle is with y-axis, so it will become x component divided by y component. Fx divided by Fy. So this implies Fx is equal to Fy tan of 30 degrees. Okay. Fx, we know, is Fy1 minus Fy3. Fy1 minus Fy3. Fy1 minus Fy3 is equal to Fy is the same. This one is now the y component. Remember, initially this was the net force. Now this is y component of the net force. 300 gamma e squared. 300 gamma e squared. And tan of 30 is 0.577, I guess. Let me check it out. Where is it? 0.577, yes, into 0.577. Now, F51, gamma, Q phi Q1. Remember, both of them are E. We're just taking the magnitude. So, E into E is E squared divided by 5 and 1 are now separated by distance x, but x centimeters. So, we'll convert it to meters, x into 10 to the power minus 2 square minus F53 gamma Q phi Q3. Again, both of them are E, so E squared divided by 5 and 3 are separated by, let's check that, 5 and 3 are separated by a distance of 10 centimeters. That did not change. Okay, we did not relocate 3. We just relocated 1. So this distance of 10 centimeter continues to be same. So 10 centimeters. So this becomes 10 into 10 to the power minus 2 square is equal to, we have 300 gamma into 0.577 into E squared. Now, gamma E squared and gamma E squared cancels out. So, we're left with, now here 10 to the power minus 4, 10 to the power minus 4. We'll take that upstairs. So, we are left here with 1 by x square minus 1 by 10 square, which is 100. Is equal to 300 into 0.577 into 10 to the power minus 4 here upstairs, 10 to the power minus 4. So this implies 1 by x squared is equal to, now this thing, 300 into 0.577 into 10 to the power minus 2 is 1.73 into 10 to the power minus 2. Okay, into 10 to the power minus 2. Minus 100, I'll shift to this side. This will become plus 1 by 100. Plus 1 by 100. Or I can write it this way, 1.73 divided by 100 plus 1 divided by 100. So this means 1 by x squared is equal to 1.73 plus 1 is 2.73. Denominator is same, 100. Let's take the reciprocal. X squared is equal to 100 divided by 2.73. So x is equal to under root of this whole thing, 6.05. Remember, x was in centimeters. So 0.65 centimeters, 0.65 centimeters. So this is the distance between particle 1 and particle 5, new distance between particle 1 and particle 5. Now if we have to write position of particle 1, which is the distance from particle from 5, this is the distance from 5, but on the negative side. So we'll have to introduce minus sign. Okay, so position of particle 1 is minus x, not just x, minus x. So along with sign, new position of 1, x1 is equal to minus 6.05 centimeters. Okay, minus 6.05 centimeters. This is the new position of particle 1. Now, what are we asked to find out in the second part? Now, we are asked to keep this particle 1 fixed here at its new position. And we have to relocate particle 3 now. Okay, we have to relocate particle 3 now. Now, what do we do by relocating particle 3? We have to bring net force back to the original direction, back here. If we want to bring net force back here, then force along x-axis must be 0. That means these two must be same again. So in order to make them same, in this part what we did is we increased F51, we increased this one. We increased it this one. Originally they were same, but then we increased it this one. Now we have to make them same again. But we cannot change this one now, because particle 1 is to be fixed at its new position. Particle 1 is to be fixed at its new position. So force on 5 from 1 will not change. Particle 3 is to be now relocated. So particle force on 5 due to 3 will change now. So we will increase this one, so that it becomes equal to this one again. So that net force along x-axis again becomes 0. And if net force along x-axis again becomes 0, net force is again now along y-axis then. So in order to bring net force on 5 back to y-axis, we have to make net force along x-axis 0. For that we have to increase F53, so that it again becomes equal to F51. In order to increase F53, we have to bring 3 closer to 5. 3 closer to 5. Now the point is, where do we relocate it? Where do we relocate it? Remember, force on 5 due to 1 and force on 5 due to 1 and force on 5 due to 3 must become same again. For making them same, remember 1 and 3 already have same charges. Charge values are same, so their distances must be same from particle 5. So if particle 1 is at a distance of x from particle 5, then particle 3 must be at the same distance, x, so that charge were already same. Now distances are same, forces will become same. If forces become same, they will cancel out. If they will cancel out, net force is only then along y-axis, because there is no force along x-axis. So for that, we need to bring particle 3 at the same distance to 5 from 5 as is 1 from 5. But obviously it's on the positive side. So particle 3's position will be plus x. Particle 1's position is minus x because it is on the negative side. Particle 3's position will be plus x. So new position of particle 3, new position of particle 3, x3 is equal to plus of this thing, plus 6.05 centimeters. Okay, plus 6.05 centimeters. Is that fine? So new position of particle 1, then new position of particle 2. Okay.